Hey everyone, so this video is going to be a bit different than my other videos. So usually, of course, I do videos on algorithmic trading with Python, um, options trading, stock trading, and AI and ML in general. But in this video, I'm going to show you how to create a question and answer chatbot for the Bible, specifically the five books of Moses, using LlamaIndex. We're going to have a very cool GUI with Gradio. And of course, since I'm an AMD guy, I'm going to show you how to use um, Ollama using AMD GPUs with ROCm. Remember, I had this Medium post how to do that. Of course, you can use any GPU you want, but like I'm specifically using AMD MI300, but this will work for any GPU. But anyways, if you needed an AMD, the instructions are here. Okay, so let's get started. So first of all, for those who are not familiar with, there's a site called Sefaria.org, which has like basically all these holy Jewish texts translated to English and in original Hebrew, Aramaic, sometimes even Arabic for things like Maimonides had like a few books in Arabic originally. So it's cool because it's a digital library and you can do LLMs and that sort of thing with it. So let me show you guys how to do it. So first things first is we want to do this just for the five books of Moses. So I'm going to show you how to basically get the five books of Moses as text. We're going to do it in English to pandas, and then I'm going to show you how to like put it into LlamaIndex and that sort of thing. But real quickly before I get into this, I for those who are not familiar with RAG, what happens is, and I hope this drawing makes sense. So basically, you have a chunk of text, like a big chunk of text. In our case, this will be the five books of Moses, and then you split up that giant text into many chunks. These could be overlapping chunks, and you have some sort of embedding model that maps the chunk into like a space of semantic similarity. So you get an embedding vector for each of these chunks, and this can be like 784 dimensions or whatnot. So then you can find like similar content to things you're interested in. So what happens with the RAG or retrieval augmented generation is the user asks a question like, how many children did Jacob have? Then the embedding model will embed the question or the query into a vector. So this becomes a vector. And then all the chunks are also vectors. And you do something like you find the k-most similar chunks using something like cosine similarity. You can also have metadata filters if you want to filter on metadata. Say you want it from specific sources or something, you can have like a metadata filter. So once you have these chunks that are most similar, then you can combine them together into LLM, and the LLM will combine those responses and get one single response that answers the question. And as you'll see shortly with the reasoning LLMs, we're going to use the Quen model from Alibaba. It really thinks and gives you a really cool answer. So I'm very impressed with this. So yeah, so enough of me talking and let's get started. So now you should connect to Jupyter with your Linux instance. And with that, what you first should do is you should install the libraries for LlamaIndex. By the way, I also have a Medium post showing you exactly how to do this with, instead of using Ollama, the local model, you can use OpenAI's API, and I'll link that Medium in the description. But because I'm using Ollama, I have to do pip install LlamaIndex core, and then LlamaIndex LLMs Ollama, and then Llama Index embeddings Ollama. So if I spelled that correctly, I installed these things. I guess I already have it installed. Okay, so now back to the Sefaria part. So as I said previously, it's a digital library of Jewish text. So you can basically go and search this on the like it has basically URLs for things. So like let's say you want Genesis, which in Hebrew is Bereshit, it's the first book. You can go to like a URL like this. So I can just do copy and paste, and I do like here. And as you see, it's like Sefaria.org API text Genesis. context equals 0, commentary equals 0, pad equals 0, language equals English. So these are the arguments, and this is like the book, the text source, and these are the arguments. So basically, we can use the request library to download this in Python, and we can pass these things as arguments, the context, the commentary, that sort of thing. So to do that, we'll do that, and then we'll put it in a data frame. So from experience, we want to do it in English first of all. So language equals English we need, and we should use pad equals 0 because that makes the format better when you're using data frames. So to do this, what we're gonna have to do is we're gonna have to iterate through the 5 books of Moses, and each time fetch the data and put it in a data frame. And you know what? We'll separate by chapter and verse. So let me show you how to do that. So first things first is the 5 books are here. So let's actually make that into a list. So I'll do book name equals this list. And I apologize ahead of time if my laptop is running out of battery. I'll have to get rid of my webcam because they're sharing the same USB port. So I'm kind of running out of ports. Anyways, so these are the book names, and we want to iterate through this and load the text. So I'm going to do import pandas as PD. I'm going to do import requests, and I'm going to do rows. We'll get row at a time. Then we're going to do for book name in book. I'll call it names, book names, or you know what? I can just do in this. Okay, so this is when we're going to take one book at a time. So let me show you how to do that. So let's first thing, let's do URL. And remember the URL I showed you was this thing, and then there was like the there was the book name and then all the other stuff. So what you can do is you can do like a f string, and then you can make the book name as like an argument, as like a parameter. So book name, and it'll fill the book name. Okay, so this is the f string. That's the URL. And if you're using the request library, you can have params for these and things at the end. So what I can do now is I can do response equals requests dot get URL params equals pad 0. That's, I told you that was useful for the data frame. Language equals English. And you can do this for other religions and other texts. I'm just showing you for the Jewish one because I happen to be Jewish. But you can do data equals response.json. And this will give you the data. And then if it's successful, you can do data equals text equals data.get text. So this gives you the text. And now let me just show you how this looks like before I'll do anything further. So let me run this, and the text will look like this. The text, is going to be a list of lists. And the list of lists will have length, number of chapters. Length is going to be number of chapters and of the first list, and the second list is going to be number of verses per chapter. So like this will be 34 chapters and 46 verses in chapter 1, 37 verses in chapter 2. So what we're going to do, we can do something like for chapter index, chapter in, enumerate text 1, for example, because that will start it at 1. And then we can do for verse index, verse in enumerate text chapter 1. What we're going to have is we're going to now do something like rows.append. We're going to have the chapter number, the book name, first of all. Book name, we're going to have the chapter index, so the chapter. And then we're going to have the verse index. And then we'll have the text itself, so it'll be verse. Okay, so these will give us all these rows we need. Just to show you guys, it'll look like this. So row 0 will be Genesis chapter 1 verse 1, when God began to create. And you see you have a lot of other footnotes and header notes. So maybe we'll clean that up when we get it into pandas. So let's actually now make this a data frame. So we'll do df bible equals pd.data frame, and we'll do rows columns equals, let's do book chapter, oops, book chapter uh, chapter verse, and then we'll do text. So this is our data frame, and we wanted to clean this up, remove these things. So we'll just split on this character and basically remove that. So I can do df bible text equals df bible text dot str dot split, and then this thing is like this dot str0, and this should clean things up. And let's also drop in a's because sometimes there's empty lines. So drop in a in place equals true, and let's hope this works. In place equals true, and now we do df bible. Let's see if this is what we wanted. So I think this is what we wanted. When God began to create, that's Genesis chapter 1 verse 1. So we have downloaded the text as a data frame, chapter and verse, which is pretty cool. So now let's talk about the LlamaIndex part. So LlamaIndex, just to refresh some of you people, is basically used to be called GBT Index. It's like basically a tool that gives you tools to do things for RAGs, like connect your own data, has all these data connectors. It has all these methods to chunk your data, split your data into parts, index your data, interact with vector stores, that sort of thing. So it's pretty cool. And it can work with all these, every LLM you could think of. I have instructions to do this with OpenAI's API if you want to do that. But we're going to use Ollama for this. So as I showed you in that very artistic work, remember I showed you guys this artistic work. We're going to need an embedding model, and we're going to need an LLM for this RAG application. So the embedding model makes all these chunks into vectors, and then the LLM puts them together. So let's set those. So we'll go back to our notebook. We're going to use Ollama. So if you don't have Ollama and you're using Linux, you can use this command, curl fssl, all this stuff. If you're using Windows, please look at the Windows instruction. But I already have it on I'm using Linux. So anyways, Windows is just a GUI instruction. So to see the models you have, you do Ollama list. And you see I have all these models. To download a model, you can do Ollama pull, and then the name of the model. So we're, for the embedding model, going to use something called nomic embed text. So I could do llama pull nomic embed text, and I'll download the model. For the LLM, we're going to use Alibaba's Quen model, and one of them is called QWQ. So you do pull. I already had it, so I did that command for no reason. But if you don't have it, that's how you download the models. So now you have to set the LLM and the Ollama model for LlamaIndex. So this is where if you were using OpenAI's API, you would set it to an OpenAI model. So here we do from LlamaIndex dot embeddings dot Ollama import Ollama embedding, and then you do from LlamaIndex dot LLMs dot Ollama import Ollama. That's the LLM, and then what you have to do is set the settings. So that's from LlamaIndex dot core import settings, and now what you do is you do settings dot LLM. This sets the LLM equals Ollama, and then the model name. We're gonna use remember when I did Ollama list, I wanted the QWQ. Let's use the full name, QWQ latest. So I'll do I think you need to use the full name or it doesn't work. Use stream equals true because we're gonna stream things. So this is the LLM. So I should comment set LLM model. Okay, and then we're gonna set embedding model. Okay, so this is settings dot embed model equals Ollama, and the only difference is this is the nomic thing. So let's copy and paste nomic embed text latest. So this is the embedding model. This is what turns text into those vectors of embedding, so we can do distance metrics. What did I mess up on? I must have made a mistake. Hmm. Oh, sorry. I did embed model equals Ollama. I need Ollama embedding. Okay, great. So now I have the embedding model. So now we need to basically, okay. So remember I told you that we're gonna chunk things. So you chunk things into documents or nodes. Node could be a subset of a document. For simplicity, let's just do documents, and we're gonna basically chunk things, and we'll chunk it by chapter. But so each chapter will be like a book and a chapter. Each document will be a book and a chapter. But because maybe in future videos I want to show you how to do metadata filters, I'll include metadata information, even though for this example it's going to be useless. So I do from LlamaIndex dot core import document, and then I do documents equals this, and then for book chapter group in df bible dot let's just do dot group by, because we wanted it on the book chapter level. So this will be for book and chapter. What do we want? We're going to want the text. So the text is just basically a lot of text together. We'll just separate it by like a new line, for example. So I could do like I could do text equals basically new line separator dot join group text, and metadata. Let's add the metadata. Just again, this is useless for this example, but in the future, if you want to filter on metadata, it's good to know that you can include that in the document. So you do book. We'll say the book name. So that's book in the group by. And we're gonna do chapter, same thing, chapter, text. Sorry, we can do something like this. We can do verse start. It's always gonna be 0, so this is stupid. I can do like int group verse dot min. So this because we're doing group by book and chapter, it takes the minimum of the verse, but we know this is always 1, so it's always going to start at 1. So this is completely useless, but I just wanted to show you for the sake of example that you can add metadata and eventually chunk this in a different way to take advantage of metadata if you want to filter on books and verses and that sort of thing. So this is the metadata, and now for the documents, we're going to do documents.append. We're going to use LlamaIndex document class, text equals text, and metadata equals metadata. I think that's it. Probably made a mistake. Let's try. Okay, it looks good. Okay, so now we're going to index them. So this is the thing that chunks things. So let me show you how it looks like actually. And sorry if I'm rushing. I'm just worried my thing will run out of battery. So again, I guess it's a good plug-in to like and subscribe if you enjoyed this video. So this is a chunk. See, it has verse start and verse end. I might have made a mistake. I always make mistakes. So anyways, oh, I did min twice. Okay, so let's do max. Again, this is useless, but just for the sake of showing you. So document 0, you see I have the chunks. This was everything combined together. I did a new line to combine it. I probably didn't need that, but anyways, these are the documents. And now we're going to index our documents. So this is means to make each of these document into vector embedding. So 768 dimensional vector. and then put it in a vector store. And so we do that by doing from LlamaIndex.core import vector store index, and we do index equals vector store index dot from documents, and then we do I think we can do show progress equals true. So if we have long documents, we can basically see the progress of those documents. And sorry that my web camera, I just ran out of battery, so you can't see my face, but it might be better that way. But anyways, it's indexing the vectors, and just to visualize this, basically I said that basically each of these documents becomes a 768 dimensional vector. So when you have a query, like you ask a question about like how many children Jacob had, you're now going to find vectors, and you that's going to be its own vector, and you're going to compare that vector to vectors in your document itself, and you're going to combine the most similar ones. So let me just give you some intuition on how it looks like. So if I do index dot storage context dot vector store dot data, you'll see how it looks like. I think this is the right command. So each of these documents will be that big vector. So yeah, so see, this is the first document, and it has a vector of all these numbers. So that's how this looks like. Let me just do that. Okay, so now let's create the query engine and chat index. The reason we need a chat engine, sorry. The reason we need a chat engine is because basically we want to chat back and forth, and we want, let's say the chatbot answers a question and this isn't complete or forgetting something. We want to be able to go back and forth. So we need memory of our previous interactions with the chatbot. So we do from LlamaIndex.core.memory import chat memory buffer, and then we do from LlamaIndex.core.chatEngine import condense question chat engine, I think. And now we can do something like query engine. So query engine is going to be index.askQueryEngine, and then we can do similarity top k equals 10. So it takes the 10 most similar documents. I found that you don't want too many, but you want enough. Like if you do less than 10, you might not get a good answer, because sometimes completely different verses you need to answer the question. So you can use 10 or more. Maybe too much sometimes runs into problems, but I found that it's better to err on the side of higher number. Of course, too much is slower, so 10 is a good number, I think. So now I can do chat memory equals chat memory buffer. This basically gives me the memory from our chats, and I'll do token limit equals 4,000. So you have 4,000 tokens in the chat memory buffer. You can increase that for more memory, but it'll be slower. Depends on your memory, of course. So now we do condense question chat engine dot from defaults. See, I really like LlamaIndex. It's nice to use. Query engine equals query engine, and I think we also need chat memory equals chat memory. Chat memory. Okay, so this should work. We have a chat engine. Ugh, what did I mess up? Token limit, not limit. Okay, so now what's cool, this is the coolest thing in the world, by the way, is this thing called Gradio. So it used to be when you created data science UIs, you couldn't really share with anyone, but Gradio gives you a link you can share with your friends, which is pretty cool. Of course, never share sensitive data. Like for algo trading, if you have an app, don't share it. But for the Bible, why not? So we import Gradio as GR. By the way, you can create like really cool dashboards with Gradio that are not even chats. But here we're going to do a chat. So the syntax is something like this. You define a function, chat inference, message history. History. And we're not going to use the history argument because our LlamaIndex handles that. But in other cases where you need to like append history, that's where it'll be useful. So now I can do something like response equals chat engine dot stream chat message. So this is what you call is you ask a message and then you call stream chat, and it basically answers the question. So it's gonna stream things one at a time. So what we want is we want it to be like ChatGPT, where it kind of writes to you. So I can write so far equals this. I can write for token. Oops. Token in response dot, and of course I have this code. I'll have this code on Medium, and I already have the version with OpenAI's API, so you don't need to memorize this. I've just done it so many times, so like yeah. Anyways, if this is an interesting thing though. We're gonna go token by token, and we're gonna yield a token where we'll eventually put it in the Gradio chatbot. But it has a problem when there's like a special character like think, so you have to skip it. So this is kind of weird, and this took me forever to get because the chatbots like ChatGPT didn't know about this very well. So if token doesn't equal think, that's a very important thing. You do so far plus equals string token. So now we do yield so far. So this is what we're gonna print each time. The cumulative string the chatbot wrote. And now to do the actual Gradio, we do gr dot chat interface, and then we're gonna do chat interface here. We can have a title. I can call it ask the Bible. And then I can do okay, so now there's two more things. You can launch it by just doing dot launch, but I always like to do debug equals true because then you get debug messages here. And you can also do share equals true. Again, for sensitive things, don't do that. Oops, what did I get wrong? Chat interface has no attribute launch. Launch. Okay, launch. Okay, so what's cool? Okay, so I have internet issues, I guess, so I can't share this app. But usually it gives you a link you could share with your friends. But for us, we can go to this like local URL, for example, and we can either go on the local URL. Let's wait for that to load, or we can actually message here. And let's go on the local URL because it's a little bit more pretty. So it's ask the Bible app. So I could say like, how many children does Jacob have? And this is what I thought was really cool because this model actually thinks like a normal person, which is cool. So the Chinese models are the best. Okay, I think China's gonna be. I mean, China's pretty good in AI. I think they're very good. So let's hope this works because I'm talking too much. But how many children does Jacob have? Uh, okay, so I need to figure out how many children Jacob has based on the provided text. So look how it's thinking. It's like searching through verses, and it's thinking out loud. Okay, so it's saying in this verse, it talks about Jacob's wives, and it talks about okay, so it knows Jacob has wives, and it lists Jacob's son. It lists the son's names by wife, right? So it says Leah has 6 kids, and then it talks about other kids from other wives, and it's kind of cool how it's thinking out loud, like the same way we would be thinking, right? Um, and yeah, it's a little slow, so sorry about that. Okay, so it's doing sons of the other wives. Uh, okay, so wait, sons are 6 from Leah. Yeah, so see, look, it adds the number of sons from each wife. So you get 8, 10, 12. But wait, it says they go to Egypt. It says the total of Jacob's household was 70 persons. Wait, 70 is not the right answer, but look at it think. It's thinking. Anyways, kind of cool, I think. It's thinking out loud. And eventually it says, okay, the sons. The, okay. Let me just shut up and let it finish. Okay. Okay. 12 sons, right? But then it's asking questions. Is this actually true? It's making sure its answer is right. It's like double checking. It's like saying, wait, 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 wait. By the way, 12 is not the answer because there's also a daughter. So, okay, so 12 sons, right? But let's wait. And oh, okay. Look how smart the chatbot is. It's asking if Jacob has any daughters, right? And then it says in Genesis, it mentions Dinah as Leah's daughter. So Dinah is the daughter. So 12 sons and one daughter is 13. So the chatbot is really smart. And by the way, the reason it was so slow is I did k equals 10 for 10 most similar documents. If you do a smaller number, it'd be much faster, I think. But kind of cool how it thinks out loud and it's like thinking like what we would think. It's like double checking and stuff. So it says, therefore, the answer should be 12 sons and one daughter, or 13 in general. And it's making sure it's answering correctly, and it's overthinking, but it's double checking because it wants a perfect answer. And it's kind of cool. It's asking if it misses a daughter, it's double checking. Anyways, I probably ruined the video by talking too much now, but la, 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 la. I don't know. It used to be faster, even though I did k equals 10. 13 children. Yay. Anyways, it's very cool how it's like a trustworthy helper, but it's a little bit thinking too much, for a video. So 13 children. Yay, it did it right. Anyways, hope you enjoyed this video. Please like and subscribe if you've never done that. Thank you so much. Have a great day.